Frequently asked questions pertaining DOE, Department of Environment Regulation, and chimney erection for a ventilation system, an industrial ventilation system. Question number one. Do I need to comply to Clean Air Regulation 2014? Clean Air Regulation 2014 is the revised regulation from Clean Air Regulation 1978 under the Environmental Quality Act in Malaysia. The purpose of this Clean Air Regulation is to enable us to control the emission, to control the impact of emission from the industries, hazardous pollutant emission to the from the industries to the environment. Now, so to answer this question, first of all, we need to check if our processes, the processes in the industry or processes in a business entity produces combustion gases from fuel burning equipment or any other processes which is to emit which is to emit significant amount of airborne hazard which could comprise from aerosol, comprised from aerosol. Aerosol are particulate or liquid, particulate or a liquid matter. It can be a fog, it can be mist, it can be dust in particulate form. See, it can be water or matter, or it can be water or solid, yeah, which is in aerosol form. Aerosol is basically fine particulates which are less than 100 micron. 100 micron is a type, I mean, is 100 microns are microscopic particles which have the ability to get suspended in the air. So that's why aerosol is classified as an airborne pollutant. Then vapor which could come from acid, which could come from VOC, which could come from any type of oxidizing, any type of chemicals, yeah, which can vaporize due to its vapor pressure, due to its low boiling temperature, due to its process itself because it undergoes heating and what's not, and lastly gases, right? Gases. Now, if your process produces these types of airborne pollutants, and then yes, you would comply to the what you call to Clean Air Regulation 2014. What I need to do as compliance to Clean Air Regulation. Once you identify, you comply. What is your action? As mentioned earlier, number one, you always anticipate, recognize, you identify, you recognize, you anticipate. That means you list down what are the chemicals involved, what is going to get aerosolized. If you're going to have a welding process or something involving metal, so you're going to have aerosols in the form of fume. You're going to have some spraying, liquid spraying process or painting, what's not. You're going to have liquid aerosols. If you're going to have some grinding works being done, or milling works going to be done, you're going to have particulate aerosol, yeah? Or you're going to have a plating process. You're going to have vaporization of chemicals like sulfuric acid or chromic acid and what's not. If you're going to have direct usage of gases, so you're going to have combustion, you're going to have oxides of sulfur, you're going to have carbon dioxide, you're going to have carbon monoxide and whatnot. So identify them. Next, define how you're going to use your ventilation system to control this airborne. Are you going to use a general ventilation? Are you going to use the local exhaust ventilation system? Once you have defined that, then engage the right kind of consultant or the right kind of service providers. We're going to use an acceptable standard. We're going to use professional engineer to get the engineering calculation done. Then you're going to notify to DOE. Notify the new term used in 2014. Prior to that, we usually will say seek permitting or seek approval. In fact, at this present moment, right after notification itself means seeking approval. So we seek approval from DOE. DOE will run through the entire design details and would give the applicant the green light, or would ask them to correct the system until it meets reliable standard. Right after you get the approval, you construct the system as according to the blueprint and the specification specified by DOE. Question number 3, what I need to do after the construction. Right after the construction, any construction, what you need to do is once it's done, first of all, you need to construct it as according to the blueprint of the system. Once the construction is done, once the construction is done, next step is to test and commission the system as according to the design point, as according to the duty point, as according to what are the flow rate it was designed for. Okay, flow rate to meet the capture velocity, flow rate to meet the air change, or whatever the objective or whatever the type of ventilation you're going to use. Once that is done, then you establish a baseline data. Once a baseline data is established, you conduct a baseline chimney emission monitoring. Once you have completed the chimney emission monitoring, then you train the user on how to do performance monitoring. What's performance monitoring? Now you have a baseline flow rate. All right. How are you going to maintain the baseline flow rate? Uh, how are you going to maintain the system operation throughout this baseline condition? What is the baseline condition, or what is an acceptable range of operation? It is the lower limit, it's within the lower limit and upper limit. For example, if you're using efflux velocity as your uh, as your performance index, let's say the baseline efflux velocity based on the testing you got 11 meters per second, and we know the lower limit is 8 meters per second. If it is a dust collector or if it is a fuel burning equipment. Now, if you're using a scrubber, your lower limit is going to be 12 meters per second, assuming that we are using a boiler or a dust collector, 8 meters per second. So now you have 11 and 8. So you keep doing periodic testing and you check within these numbers. Now, if the numbers goes below the lower limit, that shows that the system will deteriorate. System will undergo downwash. System will not have dispersion, effective dispersion. Why do I mean by that? The function of a chimney is to create plume rise, stack effective height, and a dispersion on a horizontal trajectory. We don't want a downwash where the plume is pushed down, where it undergoes a lower range of travel distance, and it will still maintain a high concentration, impacting the environment on the ground level concentration. This is the reason why we need these numbers to be adhered. All right. Now, right after that, once the users are trained, for a start, record this for 30 days. Then use these 30 days data, use the baseline chimney emission monitoring, use the as-built drawing to justify, to declare to DOE, not just to declare to DOE that you have constructed the system as according to the original blueprint during the notification submission. You have established the preventive performance monitoring. You have also conducted the baseline chimney emission monitoring to basically declare to DOE saying that, hey, look, I've done, my systems are good, it's good to go, and I'm ready to operate. Okay. Uh, Question number 4, how soon do I need to conduct chimney emission monitoring and how frequent? Now, prior to Clean Air Regulation 2014 revision, the emission monitoring usually conducted on a quarterly basis. But right after, in 2014, uh, the minimum number, the frequency is very much depending on how the system is designed, depending on toxicity of the chemical and what's not. Now, let's say the system undergoes deterioration or fluctuation of flow rate pretty frequent, then you have to decide to do it on a very frequent basis. I mean, maybe quarterly, maybe twice, 3 times a year, or what's not. But if the system is stable, then once a year is the minimum requirement, right? Now, the moment you test commission, the moment you start operating, the baseline emission monitoring must be conducted 3 months after the operation, but not later than 6 months. However, as I mentioned earlier, since we are already supplying, giving the declaration together with the performance monitoring data and what's not, it is becoming a common practice now that most of the state DOE are requesting for the chimney emission report together. So we would strongly recommend that conduct your baseline chimney emission monitoring the moment your process is already stable, the moment is running together with your baseline condition so that the report can be submitted during the declaration process to DOE. Question number 5, why do I need to conduct performance monitoring? What is performance monitoring? Now I established a system. I have established a design and I've told DOE, hey DOE, my system is running. I have conducted my first testing I'm submitting you a report, yeah. So you're giving them the baseline condition. But how are you going to ensure this baseline condition is always maintained on a straight line? You can't, because in ventilation, you're bound to have deterioration of the flow rate of the system because of clogging in the filter, because of bearing wear and tear, because of the belt is having wear and tear and what's not. So there are various resistance build up and predictive maintenance requirement or wear and tear, which will deteriorate the flow rate. So the reason why we need to do performance monitoring is to log how low the how bad the deterioration takes place. We want to ensure that the deterioration doesn't go below the acceptable level, because if it goes below the lower limit, you're going to start impacting the environment. So you stop, you trigger for preventive maintenance, correction maintenance, then you bring it back to the baseline condition or LP condition. So deterioration will take place in the long run. Stop maintenance, deterioration, stop maintenance, improve, deterioration, stop maintenance, improve. So that is how the cycle goes. That is why, in order to make this cycle feasible, you need the performance monitoring. Now, what happens if you don't do performance monitoring? You have reactive maintenance, which means you are not going to know that the system is running at efflux velocity 5. You're not going to know if the bearing is going to fail. You're not going to know if the belt is going to have the RPM of the fan is already deteriorating. You're not going to know the capture velocity in the hood, transfer velocity is reducing, causing more settlement of dust, what's not. If you do not conduct, or you're not going to know that the filter is choked until the filter is completely choked, and then it will incur more current. Then it will trip the overload, and the entire system will go idle. So you don't want to have this kind of thing. On top of it, a good preventive maintenance will enable you to plan your you schedule your stoppage time, so that in the system, the entire ventilation system doesn't stop in right in the middle of a peak production schedule. You have regulation 8, which clearly specifies that every single system, engineering control system, must operate without failure, must be operated without failure when you're running the production. That means assuming that your system failed, but you're still going to run the production, then it's a violation of the regulation. So this is why you cannot have reactive maintenance. This is why you need to do performance monitoring.